Engineers design for the forces they can see: heavy impacts, violent vibrations, and extreme heat. We armor products against these dramatic threats from the very beginning of development, ensuring they survive the obvious dangers of their environment. But there is a massive blind spot in that armor. Almost no product is specified to withstand the bottle of standard cleaner someone will spray on it twice a week for 10 years. For a massive class of manufactured parts, that routine cleaning agent is structurally the most aggressive adversary the object will ever meet. The sensation of a soft cloth on a surface is misleading. In reality, these cleaners act as relentless chemical solvents. When we ignore routine cleaning as a fundamental physical load, we leave an unquantified vulnerability in the product's lifespan, setting the stage for a total failure. This failure, environmental stress cracking, is unique because it requires two distinct causes to intersect before the material gives way. The first cause is chemical exposure. A plastic part submerged in an aggressive cleaning fluid is perfectly safe on its own. The second is mechanical strain. That same part, bent under a modest load, will also remain intact as long as it stays dry. The failure happens at the intersection. When you combine the chemical and the strain, the molecular lattice shatters at a fraction of its normal tolerance. If the gentle pressure of a cleaning cloth isn't enough to trigger this, we have to find where the destructive strain is actually hiding. 40 years ago, the automotive industry documented this exact phenomenon, proving how standard windshield washer fluid destroys strained polycarbonates. Even without a total shatter, chemical friction relentlessly degrades the finish. Gloss falls, color shifts, and textures polish flat where hands and cloths touch the surface. The mechanical strain required for this damage is already locked inside the object before it ever leaves the factory. This internal tension is a remnant of the manufacturing floor, specifically the intense pressures used during injection molding. As the plastic flows and cools, it leaves permanent stress zones concentrated near gates, ribs, and anywhere the material had to knit together. Assembly makes this worse. Snap fits and torqued screws hold the product in a state of permanent, unrelaxing tension. The product spends its entire life fighting a hidden physical battle with itself long before a chemical cleaner ever touches its surface. Traditional concept drawings and CAD specifications don't show these preloaded internal stresses. Design teams often choose gate positions and assembly methods to optimize for speed and cost, unaware of the chemical vulnerability they are creating. These early manufacturing choices dictate exactly where the cleaning product will eventually crack the shell. A product's integrity is defined by how it survives its 1,000th chemical clean, far beyond its initial debut in a showroom. A product never looks like its marketing photo. It spends its life in the state of its 1,000th clean. Design decisions are cheap as a sketch, brutal once tooled. See every angle before you build.